Okay, so spawner is responsible for spawning the current wave. Um, this is spawner right here. It's a singleton. So all the wave data is stored inside of a text file. The file is then read by a parser, and what this parser will do is it'll take that text, it'll read it, it'll process it, it'll then turn the data into actual wave objects. So what wave objects are, they're just objects that store all of the variables that pertain to a wave, such as the length of the centipede, the speed of centipede, speed of various other critters, and their spawn rate. Um, yeah, and then all of the waves are then stored inside of the spawner inside of a vector. Yeah. So where is it? Okay, so the parser calls create wave, creates the wave, and then the parser will then just set the variables for that wave as it iterates through it. So how the spawner works, when a new scene starts or the player dies, spawn wave will access the current wave of the player, usually through the player manager, and then it'll call the individual spawners for each of the critters. So the centipede spawner, it's called immediately. The other spawners, they use alarms. So yeah, so this spawner essentially just takes the variables from the wave and then just passes them down into the individual spawners. Those spawners then create more data. Usually they come up with some position and then position vector, and then they pass that, the variables from the spawner and the data that it comes up with by itself, passes all that to its factory, which actually creates the enemy object. So yeah, just to give a better look into that, I'll pull up the scorpion spawner. So when alarm one's called, it creates a new, calls scorpion spawner, tells it to create a new scorpion. So that takes us here. Scorpion spawner is a singleton. All of the spawners are singletons. Yeah. So all scorpion spawner does is it tells the factory to create a new scorpion. So create scorpion. It'll do some various calculations. Using random number generation, it'll come up with a starting direction. So it'll either start on the left side or the right side, depending on the random number. It'll then re-roll that number in order to get its Y position for its position vector. So yeah, this gets a random vector within a certain range. And then it takes the vector that it creates and the direction that it found and the rate, and it passes it to the scorpion factory, also a singleton. They're all singletons. All of the critter factories are singletons. And then this will actually create the scorpion object. Because it's a factory, it also has a pool. So I'm not constantly creating new scorpions. I'm recycling some of them. So yeah. So private create. So create the scorpion. If one doesn't exist in the stack, then I'll create a new one. Otherwise, I'll just pull one off the stack. I'll then initialize it. Yeah, initialize it right here. Oh, also it's worth mentioning that if the player dies mid-wave or for some reason I need to wipe the wave first for whatever reason, spawner will call wipe all critters. And what this will do is it'll call the factories. So going back to Scorpion factories, which will wipe out all of the active instances of scorpions. So along with storing all of the inactive scorpions inside of the scorpion pool, I also have a pool that stores all of the active scorpions. This just helps with if I ever need to clean up the grid, I'm able to do that. So yeah, it just goes through the active pool, destroys them, and then cleans the active stack. And yeah, that's my overall spawner. So now getting into the individual critters. Scroll. Okay. So let me start with Scorpion. So all of the scorpions derive from the enemy class. This really just helps with setting up collisions between bullets and enemies. I don't have to create a I don't have to register a collision between each individual critter and the bullet. I can just register the bullet to enemies, and since they all derive from that, I don't have to do that multiple times. Same thing with the ship. So yeah, back to Scorpion. So Scorpion's pretty simple. It just moves horizontally once per grid space. Let's see. So yeah, update, move, it's move. Sorry. So I'll go into move. Check its distance counter. Distance counter is equal to the size, the width of a of the grid space. If distance counter equals 0, that means that the Scorpion is in a new grid space, and therefore it needs to run the collision checks accordingly. So yeah. So if it's in a new grid space, then I'll run the collision checks. I'll go down here. If it reaches the border, then it'll destroy itself. If it's a mushroom, then it will set the mushroom to poison state. So yeah, that's Scorpion. Flea. Where's Flea? Here's Flea. So, actually, better yet, before I talk about Flea itself, I'm gonna pull up mushroom. So when a mushroom is deleted or ready to be deleted, it will make a call to the spawner and tell the spawner to spawn a flea. It'll call spawn flea on the spawner, and it will pass back the number of currently active mushrooms to the spawn flea method. So where's my spawn? Oh, here it is. Okay. So what that'll do is it'll just check to see if the number of active mushrooms, mushroom count, is less than the number the flea count uh flea count number, if that makes sense. So like the flea count number is basically the least amount of mushrooms needed to be present for a flea not to spawn. So if it's less than that, then it'll spawn a flea. And yeah, hopefully that made sense. uh, so okay. So like the scorpion, actually all of the critters do this. Um, it'll only check for collisions once per grid. So down here, it uses the same method, distance counter. If it's less than 0, run the collision checks, reset your distance counter. For the collision checks, it checks to see if it hit the bottom, if it hit the bottom of the screen. If it did, then it deletes itself. Otherwise, it checks its current position. If there is a mushroom there, and it won't do anything. However, if the space is empty, there is a chance that it will spawn a mushroom. And also, if the flea is hit already, then its speed is equal to its drop speed. After it's hit once, then it stops dropping mushrooms. So this effectively prevents the flea from dropping any more mushrooms after it's been hit once. Yeah. So moving on to the spider. Let's see. It's recording, right? Yeah, it's okay. Phew. So the spider, what's special about the spider is that it uses a finite state machine to get its movement, much like the AiMovement in the ship. So getting into the update state, it grabs its next state. The current state gets its next state. I'll then update its position. Vector. Okay, so now actually looking at the states, start with this one. Actually, better yet. Okay, so this is the base class for all the states. This is what all the states derive from. So the states will override these two methods. And yeah. So yeah, these ones override it. And then all instances of, no, that's the wrong thing. And then all instances of the states are stored. Static instances of the states are stored inside of the spider finite state machine. This way, like, I'm not creating, there's only one instance of each state that exists at a time. I'm not creating multiple instances of the same state. So yeah. So now actually looking at a state. So for the get next state, what it does is, just like the flea and the spider, the flea and the scorpion, it checks when it enters a new grid space. However, after it checks to see if it's a new grid space, it'll check to see if it hit a lower bound. It checks the lower bound specifically because it's heading down and diagonal. If it was heading up or up and diagonal, then it'd be checking its upper bound. So yeah, this just limits the amount of conditional checks that I'm making every update. So say I hit a lower bound, then I'll either go into the up left state or the up diagonal left state. I feel like it's worth mentioning that the spider doesn't change its x direction, it'll change its y direction. So, for example, say it starts on the right side of the screen, and in that case, it'd be calling one of its left movements. So it'll only be moving left. So diagonal left, up left state. Let's say it goes up left state, up left, and goes to diagonal left, down diagonal left, down diagonal left. So yeah, it's never gonna switch into the states that are heading right. It'll stay only in the left-headed states. So yeah. So actually, now that I mentioned the spider state, I should go back to the player movement AI states. Sorry. So going back to the AI movement for the movement controller, it's basically doing the same exact thing as the spider states. It has base class, which all the states derive from. It has static declarations, which prevents the which limits the amount of states that need to be that only one instance of each state exists at a time. I think I said that right. I hope so. So yeah. And then actually, let me pull this up. And then just like the spider, when I'm updating my position, I'm updating my move. I'm also checking my next state. Say I'm in down diagonal left. If I enter a new grid space, just like the spider, I'll run an additional check to make sure whether or not I hit a lower bound or not. If I did, I switched to the left state. The only real difference between the AI movement and the spider state is that the AI movement also checks to see if it hits its left or right bound. So since I'm heading left, I only have to check my left bound. If I hit my left bound, then I reverse my x direction. So instead of heading left, now I'm heading right. So yeah. So yeah, that's the critters, and it's also the AI controller in more detail.